Welcome, future tech innovators. Today we're diving into the exciting world of model deployment and serving. It's all about bringing your smart models to the real world. Let's explore our first question. What are common methods for deploying a machine learning model? There are four main approaches. Cloud platforms like AWS SageMaker, Google Cloud AI, and Azure ML. Container solutions using Docker plus Kubernetes. Serverless options like AWS Lambda and Google Cloud Functions, and API frameworks including Flask, Fast API, and Django REST. Now, let's look at the analogy section. Think of deployment like opening a restaurant. You need a location, which is your cloud, kitchen equipment, which are your containers, staff, which are your APIs, and a way to serve customers, which are your endpoints. Our second question: how do you ensure a model is scalable for high-traffic requests? You need four key strategies. Load balancing to distribute requests across multiple servers. Auto-scaling to automatically add or remove servers based on demand. Caching to store frequent predictions and avoid recomputation. And batch processing to handle multiple requests together. Now, let's check the memory tip section. Labs, load balancing, auto-scaling, batch processing, store, which means cache. Let's dive into API communication methods. This is where your models talk to the world. First question: what are the pros and cons of using REST APIs versus gRPC for model serving? REST APIs have clear advantages. They're easy to understand and debug. They work with any programming language. They use human-readable JSON format. But they're slower due to JSON parsing and have larger payload sizes. gRPC offers different benefits. Super fast binary communication, built-in streaming support, automatic code generation. However, it's harder to debug and has limited browser support. Here's our analogy section. REST is like talking on the phone, clear and easy. gRPC is like telepathy, fast but needs special skills. Second question: what is model drift and how do you detect it? Model drift happens when your model's performance degrades over time because real-world data changes. Detection methods include monitoring prediction accuracy over time, comparing input data distributions, tracking business metrics like sales and clicks, using statistical tests like KS-test and PSI, and setting up automated alerts. Let's look at our analogy section. Like a basketball player whose shots start missing because the hoop height changed, you need to notice and adjust. Time for smart deployment strategies, the clever ways to update your models safely. First question: how do you automate the rollback of a bad model deployment? Here are the automated rollback steps. First, health checks to monitor key metrics continuously. Second, threshold alerts to set error rate limits like greater than 5% errors. Third, automatic triggers with scripts to revert to previous versions. Fourth, version control to keep multiple model versions ready. Fifth, circuit breakers to stop bad models instantly. Now the tips section reminds us, always have a panic button. Automated systems should detect problems faster than humans. Second question: what is A/B testing in ML model deployment? A/B testing means running two model versions simultaneously to compare performance. The process involves splitting traffic 50-50 or 90-10, comparing business metrics, measuring statistical significance, choosing the winning model, and gradually shifting all traffic. Our analogy section explains, like testing two pizza recipes, serve half customers recipe A, half recipe B, see which gets better reviews. Welcome to Pro Deployment Techniques, Advanced Moves for Deployment Masters. First question: how do you implement Canary deployment for ML models? The Canary steps are: deploy new model to small percentage of traffic like 5%. Monitor performance closely. Gradually increase traffic to 10%, 25%, then 50%. Full rollout if successful. The analogy section tells us, like a canary in a coal mine, test with a small group first. Second question: what is blue-green deployment and how does it work in ML? In blue-green deployment, blue represents your current production model. Green is your new model version. You switch traffic instantly between them with zero downtime deployment. The tips section reminds us, like having two identical restaurants, switch customers instantly. Third question: Explain model registry and its importance in MLOps. A model registry is central storage for all model versions, metadata, and performance metrics. Benefits include version tracking, reproducibility, collaboration, and governance. Fourth question: what are shadow deployments? In shadow mode, the new model processes real requests but doesn't affect users. Use cases include testing performance safely, comparing with production, ensuring no user impact, and collecting real-world data. Let's get our hands dirty with hands-on implementation. First question: how would you deploy a PyTorch model using TorchServe? Now, let's look at the code section. We have 3 main steps. Step 1 is install TorchServe. Step 2 is archive model. Step 3 is start server. Second question: how can serverless functions like AWS Lambda be used in model serving? Serverless benefits include paying only when used, auto-scaling, no server management, and being perfect for sporadic requests. However, there are limitations: 15-minute timeout, memory limits, cold start delays, and large model challenges. Our analogy section explains, like hiring a taxi versus owning a car, great for occasional trips, expensive for daily use. Time to explore model packaging and containers, the art of wrapping your models perfectly. First question: what is the difference between model packaging and model serialization? Model serialization means converting model objects to storable format like pickle, joblib, or ONNX. Model packaging means bundling model plus dependencies plus code plus metadata into a deployable unit. The analogy section clarifies: serialization equals writing a book. Packaging equals putting the book in a box with instructions and tools to read it. The tip section reminds us: serialize to save, package to deploy. Second question: how would you containerize a scikit-learn model? Now, let's look at the code section with our Dockerfile example and build and run commands. Let's tackle NLP model deployment challenges, the unique hurdles of language models. First question: what are the typical challenges in deploying NLP models? The major challenges include 6 key areas. First, model size. BERT and GPT models are huge, measured in gigabytes. Second, memory requirements. Transformers need lots of RAM. Third, inference speed. Complex attention mechanisms are slow. Fourth, language variations with different languages and dialects. Fifth, context length due to limited input token capacity. Sixth, real-time processing because users expect instant responses. Our analogy section explains, like hiring a genius professor, brilliant but needs big office, expensive salary, and time to think. Second question covers solutions for NLP deployment. Optimization strategies include model compression through quantization to reduce precision, pruning to remove unnecessary weights, and distillation to train smaller student models. Infrastructure solutions involve GPU acceleration, model caching, batch processing, and edge deployment. The tips section advises: use ONNX format for 2 to 4 times faster inference. Welcome to model monitoring and logging, keeping your models healthy in production. First question: what metrics do you track for a deployed ML model? Performance metrics include accuracy, precision, recall, F1 score, response time, throughput, error rates, and timeout rates. Business metrics cover conversion rates, revenue impact, user satisfaction, and engagement. System metrics track CPU/memory usage, disk I/O, request volume, and queue depth. The analogy section explains, like monitoring a patient's vital signs, check heartbeat, which is performance, temperature, which is errors, and blood pressure, which is load. Second question: how do you log model predictions and ground truth for monitoring? The logging strategy includes what to log: input features plus predictions, confidence scores, timestamps and user IDs, and model version used. Ground truth collection involves user feedback loops, delayed labels from surveys, expert annotations, and business outcome tracking. The tips section reminds us: store everything in structured format like JSON for easy analysis later. Time for data quality and drift detection, catching problems before they catch you. First question: how do you detect data quality issues in production? Detection methods include missing value checks, range validation, schema validation, statistical anomaly detection, and data freshness checks. The analogy section explains, like quality control in a factory, check every part before assembly. Second question, what tools do you use for monitoring ML models in production? Popular tools include MLflow for experiment tracking, Prometheus for metrics collection, Grafana for visualization, Evidently for data drift detection, and weights and biases for ML monitoring. Third question, what is concept drift and how is it different from data drift? Data drift means input data distribution changes. Concept drift means the relationship between inputs and outputs changes. The analogy section clarifies, data drift is moving the dartboard. Concept drift is changing the scoring rules. Fourth question, how would you track model accuracy over time? Tracking methods include rolling window accuracy, daily or weekly batch evaluation, confusion matrix tracking, performance dashboards, and automated reporting. Let's master advanced monitoring techniques, the early warning systems for your models. First question, what alerts would you set up for a production model? Critical alerts fall into 3 categories. Performance alerts include accuracy drops below 85%, response time greater than 2 seconds, and error rate greater than 5%. System alerts cover high memory usage greater than 80%, queue backlog greater than 1,000 requests, and service unavailable. Data alerts include missing features detected, data drift threshold exceeded, and unusual traffic patterns. The tips section advises, set up alerts that wake you up at 3 a.m. only for things that truly matter. Second question, how can you identify bias in a model in production? Bias detection methods include statistical tests to compare predictions across demographics, measure equality of opportunity, and check for disparate impact. Monitoring approaches involve A/B testing across user groups, tracking business outcomes by segment, user feedback analysis, and regular fairness audits. The analogy section explains, like checking if a judge gives fair sentences, look at patterns across different groups. Time for production validation and logging, the final quality checks. First question, describe how to log feature importance or SHAP values in production. The implementation strategy includes calculating SHAP values for sample predictions, storing top K important features per prediction, aggregating importance scores weekly, and tracking feature importance drift over time. Now, let's look at the code section, which shows how to log predictions with SHAP values. Second question, how do you validate data pipelines in production environments? The validation framework includes data quality tests for schema validation checking column types and names, range checks for min/max values, null value thresholds, and duplicate detection. Pipeline health involves data freshness checks, processing time monitoring, error rate tracking, and dependency validation. The analogy section explains, like quality control in a factory assembly line, inspect at every step before the final product. The tips section reminds us, fail fast principle, stop the pipeline immediately if critical validation fails.